Hello, everyone. A quick yes or no in the chat if I'm audible and visible. Wonderful. So we are still 6 minutes away from the session. So the time is 8 p.m. IST here. So right now we are at 7:54. So we'll wait for 5-7 minutes for other people to join, and then we will start the session. Okay. So in that meantime, go ahead, take your diaries or take your notebooks, drink some water, and come back. This is going to be a long session. So keep yourself recharged. Yes. This is being live streamed on YouTube, and recording will also be sent for the people who remain till the end and submit the feedback form. Yes. Can you guys quickly tell me which city are you logging in from today? New Delhi, Bangalore, Hyderabad, Pune, Vijayawada, Navi Mumbai, Hyderabad, Bangalore, United Kingdom, Kuala Lumpur, Dhaka, Munich, California, Frankfurt, Lahore, Kathmandu, Adelaide, Hyderabad, Lahore, Pakistan, Nigeria, Lagos. Yes. Don't focus on the recordings, everyone. I'm sure you have recordings and YouTube videos of so many things that you have never watched. So try to make the best of the moment. Forget everything for the next 2 hours. Try to focus on the session. we'll make the recordings available. Yes. Cool. Let's play a quick game. Can you guys tell me your city without naming your city? Tell me your city without naming the city. Yes. Fog and smog. Yes, I could see a lot of references to Bangalore, Delhi, and Mumbai. What about others? Yeah. Chennai, MST. Wonderful. Cool. I think we are right on time now. I think we can stop the game and go ahead with the session. Cool. Yes, no sharing of links, everyone. That will spam the group. Okay. So, guys, I'm going to stop the session for some time, stop the chat for some time so that everyone is able to focus. Yes. So, let me just go ahead and stop sharing the screen and present myself. Okay. So, yes, I hope I am clearly audible, clearly visible, and you guys are able to see what I'm trying to tell you today. Okay. Now, in today's session, I have few requests from you. One request is please don't try to distract yourself. Distract means that you might be having a phone, you might be having so many people around you. Try to focus on the session. Okay. Although we are going to provide you the recording, so people who remain till the end of the session, we are going to share a feedback form. Everyone who fills that feedback form, they are not only going to get the recording, but they will also get the resources, the slides, the notes, and everything else that I'm mentioning in the chat today, right? In the course today. Okay. But my personal recommendation to you would be that please do not rely on the recording, right? Because I'm sure you might have seen, you have so many videos in your saved list, but you have never watched them. Okay. So please don't do that. If you have committed 2 hours for this session, please take the best of that session. Okay. Second is go ahead, have a notepad or notebook along with you and make sure that you are writing the notes. Okay, I'll try to repeat things a couple of times so that you have time in order to note it down. Okay, so with that being said, I'll go ahead and start the session. I'll open the chat in between, I'll close the chat in between to keep it interactive. Plus, I would request everyone to please do not post any comments or any links in the chats or put up any kind of harsh comment for anyone else. I have tried to make this a public session by trusting that people who are logical, who are, let's say, good to others and kind enough are going to join this class. Okay, so we will go ahead and respect everyone's privacy as well. Okay, so with that being said, let me just go ahead and start the session. Yes, let me see if there is some kind of focus mode. Hmm. Yes, cool. So I've started the focus mode now, and you should be able to see me and you should be able to see content now. Okay. Now, everyone, today's session, today's and tomorrow's masterclass in on AI product management. Okay. And in these sessions, we are going to cover these topics. Okay. Look at this very carefully. I have divided the 2 day masterclass or the 4 or 5 hours of content into 3 parts. Okay, look at this very carefully. The first part is Gen AI fundamentals, right? No matter you want to become a product manager, a project manager, data analyst, engineer, designer, anyone, these are basics for everyone. Okay, so this is an important part that you need to go ahead and learn. And it talks about, yes, it talks about Gen AI value stack, as in how to think about building something with Gen AI, right? How the business stack looks like. Second is I'm going to tell you how large language model works, because all of that fiasco around Gen AI is going on. The base of all of that is large language models. So I'm going to tell you how do they work, right? Even if you are from completely zero non-tech background or zero tech background, I would say, it is my promise that you'll be able to understand what I'm trying to say. Okay. The second part is, yes, the second part is building AI products. So once we have understood what are the basics, we are going to talk about how do you think about building AI products. So we'll talk about the role of an AI product manager. We'll talk about nature of large language models that you need to take care of. And we'll talk about context engineering, where we'll talk about prompt engineering, RAG, and fine tuning, right? Some of it we are going to cover today, and most of it we are going to cover tomorrow. And eventually, to put everything to practice, I'm going to give you some real examples of how AI products look like. So I'm going to show you some AI agent, how to build an AI agent, basics of an AI agent. Plus, I'm going to tell you how these products actually work. So Chat PRD, Glean, Notebook LN, Gamma, they are like big companies right now. They have just started in the last 3-4 years. So I'm going to tell you how these companies' products are actually working, right? And what you can learn from them as a product manager. So we are going to do real product teardowns, right? So this is the agenda of the session today and tomorrow. Okay, can you guys quickly tell me in the chat, out of all of these topics, which topic are you most interested in? Tell me in the chat, out of all of these topics, which topics are you most interested in? Wonderful. Yes, amazing. Let's go ahead now. Yes, a lot of helpful answers. Now let me go ahead. Yes. And the purpose of this masterclass is not to make you a pro AI product manager or a pro AI engineer in 2 days, that I cannot do at least. But the purpose of this masterclass is to give clarity. Okay, so understand, guys. The problem with learning is not that today you don't have enough content. There is enough content. But the issue is that content is so much that most of you are overwhelmed, right? I hope I'm audible to everyone, right? A quick yes or no in the chat if I'm audible. Yes, cool. Wonderful. I'll just increase the voice in case it helps. Just give me a moment. Yeah, I've increased the voice a bit. So yes, it should be better now. Okay, cool. Thank you. Cool. So yes. So the purpose, so this is what we are going to learn in today and tomorrow session, this masterclass. And the purpose of this session is to give you clarity. Understand what is happening in product management world right now is there is so much content that people are very much afraid. They are feared that whether I should read this, whether I should read that. And apart from this, they are also afraid that if I do not upskill into PM AI, how my career is going to look like. So my purpose from these two sessions is to give you clarity, as in these are the fundamentals. If you focus on these fundamentals, then you just need to trust yourself that you are going to figure everything out, right? You have figured out so many things in your life, right? In your job, 90% of the things that you are doing right now, you did not knew how to do them, maybe when you joined the job, right? But now you have figured it out. So trust yourself that you have the potential to figure things out, but be ready with the fundamentals. So those fundamentals and mental models I'm going to give you today, right? So the purpose is to give you clarity. right? Now, yes. Now let's go ahead and talk about the Gen AI revolution. Okay, but before that, let me go ahead and ask you people. Okay, yes. So everyone, please tell me in the chat that what is your major outcome that you are looking from this program. Tell me in one or two or three words, what is the outcome that you are looking from this particular 2 master classes. If it is clarity, you can write clarity as well. Yes, cool. Wonderful. Amazing. Cool. So I think everyone is aligned, right? So this call is going to give you clarity and confidence so that you are able to start a good foundation on AI product management and in a generic way learning AI as well without overwhelming yourself. Okay. And understand, I have been able to train so many people, learn with so many people, talk to so many people, consult so many people that what I'm teaching you today, right now, has been vetted across multiple people and multiple industry leaders. Okay. So you can trust the content. Now going ahead, let me start the session formally. Okay. So right now we are in a Gen AI revolution, right? If I have to, so if you go to LinkedIn, you'll be able to see AI everywhere. If you go to YouTube, AI is everywhere. If you go to your job, AI everywhere. Your CEO is talking about AI. Your finance is talking about AI. Juniors are talking about AI. So everyone is talking about AI. Okay. But if we want to go ahead and capture this Gen AI revolution in the form of numbers, this is what I'm going to show you. Okay. So OpenAI, Anthropic, and Grok or XAI. These were the companies that did not existed in this form just a few years ago, right? Before 2020, most of the people did not, at least the common people did not know about OpenAI. People did not know about Anthropic because it was not there. Grok AI is recently created. Now these companies are worth 500 billion, 183 billion, 200 billion dollars, which are bigger than the whole valuation of bigger companies such as Tata and Reliance, right? Similarly, the old giants, Microsoft, from 1980s to 2022, Microsoft got a valuation of $1.8 trillion. In the last 4 years, they have got from 1.8 to almost $4 trillion, which is they have added two more Microsofts in the last 3-4 years, right? Then Google has been doing amazing. I think their recent valuation has gone above Apple as well, right? Similarly, Meta, they have gone from $300 billion company to $1.8 trillion company, right? And you have also seen Nvidia, which has gone 10x because of the Gen AI revolution, because they create the chips on which all the Gen AI LLMs run, right? Now, we also have some new age companies which even did not exist just 3, 4, 5 years ago. Okay, they are not creating their large language models, but they are just building application on top of the same. Okay, so Cursor, Glean, 11 Labs, Perplexity, Gamma, and so many other companies are there which are now building on this, and now they are also having so much value in themselves, right? So this is the Gen AI revolution that we are talking about, and market is actually putting money in the same. Okay, however, what happens is it could be true that we are in a bubble. Why? Because valuations could be abrupt, they could be non-logical, and we have seen this in 2000s when the valuations of some dot-com companies were very, very huge. Okay, and the market crashed down. Okay, so it might be possible that we are in a bubble, but whether it's a bubble or not, I'm going to ask you in the next session. Next slide. Okay, so can you guys quickly tell me in the chat? Can you guys quickly tell me in the chat the answer of this question? When was the last time when you have used ChatGPT or Gemini or Claude? Yes. Right. I got the answer. Yes. Yes. Someone said a couple of days back, I think they were on a holiday where internet was not available. Yes. So all of us are using these technologies, right? So what happens is, guys, before this, there are many bubbles. There was a crypto bubble, there was an NFT bubble. Okay. Because of which people have lost trust in technology and people have become cynical. And there is a reason to be cynical because we have seen these kind of waves. But this time, the wave looks a bit real because this technology has found its way in our delay usage, right? This technology has found its way in the daily usage. Even if your company tells you that please don't use GPT, you are actually using GPT outside of work, right? You have your personal accounts on GPT. So because this technology has found its way in daily use, it is possible that we are actually onto something which is very, very helpful. Okay. And if you want to compare, look at this right now. So if you look at I'll go back in history. So in 1980s, an initial version of internet called as ARPANET was created. Okay. After that, in 1996, we got something called as Amazon. And then in 1997, we got something called as Google, right? We called something such as Google. After that, in 2002, 2003, we got Amazon Web Services. After that, in 2004, we got Facebook. Then eventually, we keep on moving. In India, in 2008, 2009, we got Flipkart. After that, in 2016 or 17, we got this TikTok, right? In 2018-19, we got companies like Zomato, Swiggy who started to deliver, and now things are going on, right? So understand, internet has taken so much time to evolve from here to here, but right now the most valued company that you see are almost all internet based companies. Most of the value that is created by, like, most of the value creating companies are internet based companies. Okay, right now understand that AI is in its very early stage. There are so many things to figure out. Okay, but we are able to see a strong adoption of AI as a technology, which we have never seen with any other technology. Right? With internet, the issue was there was no access, there were no devices, there were no wires, there were so many issues. Right? There were no possible business models. But now with AI, we are at a point where almost everything is ready. We are just figuring out the use cases. If we can take so many years in internet to find use cases, why do you think that all the AI use cases humans will be able to figure out right now? Right? So AI is generative AI is a technology which has a lot of potential. You should think it in this way, that generative AI is actually going to put a brain over your software. Right? It is going to put a brain at scale over your software so that you are able to take decisions. Right? Everyone, a quick yes or no if you are able to understand this concept. What is the GenAI revolution and why it is actually something that you should care about? Wonderful. Now, what is the base of all this? Why this is happening? Okay. So the base of all of this GenAI revolution is actually something called as a large language model. Okay. Something called as the large language model. Right. So GPT, Claude, Notion AI, any of the AI, generative AI tools that you use these days, they are powered at the back end by some kind of large language model. Right. The large language model is a neural network trained on massive amounts of text to learn patterns in a language, enabling it to understand, generate, and reason with natural language by predicting the next most likely word or token in context. Right? So this is a Wikipedia definition. I don't want you to remember this. Understand, a large language model is simply a next word predictor. It is simply a next word predictor in that context, right? To give you an example, let's say I give the large language model, I have a large language model such as GPT, Claude, or anyone. I give it a sentence. Absolute honesty is not always the most. So the large language model, what it will do is it will try to just predict the next word, right? So it will predict the next word, which is diplomatic. After that, I'll again put the same sentence with the added word to the LLM. Then it will predict the next word, which is nor. I'm going to add everything, then I'm going to put it again. When I keep on doing this, I will get the whole sentence. Okay, I'll repeat this again. I have this sentence, I put it to the large language model. The large language model will tell me what could be the next probable word, which is diplomatic. I will take diplomatic, add this, and then I will again feed it to the large language model. Then large language model will just give me the next word. And then I'm going to again put it and keep on doing this unless the sentence is complete. So what is the large language model doing? Large language model is the next word predictor. Or word is not a correct word because these machines do not understand words. They do not understand language. Okay, they understand something called as tokens. So I'm going to come to what tokens are. Okay, so what is a large language model? Large language model is a next token predictor. You give it a sentence, it tries to complete it iteratively. Right? Can anyone tell me which quote, like which movie is this quote from? Can anyone tell me which movie is this quote from? Tell me in the chat, guys. Yes. So this was actually said by an AI, which is stars. Yes, a quick yes on everyone if you are able to recollect now. How many of you know about stars and interstellar? Yeah, everyone should watch that movie. So you guys might have seen that chat GPT is generally very diplomatic with you people, right? Right, chat GPT is very diplomatic. It is generally appreciative of whatever you do. It hides the very critical feedback from you. Okay, this is the reason, this quote is the reason behind that, right? Cool. Now let's talk about, so I have told you that LLM is a next token predictor. But how does that happen? How in the world does that happen? Okay, so let me tell you. Okay, first of all, let's talk about tokens. Look at this very carefully, guys. I'm not going to repeat this, and this is a very important part. Okay, so let's say we have a sentence. The sentence is, he lives near the river bank. This is the sentence, right? So understand, this sentence is words. This sentence is English. The machines have no ability to understand this. Machines can understand numbers and mathematics and vectors and arrays and these kinds of things. They cannot understand this. They can only understand numbers. So what we do is, we try to tokenize this. Tokenization means for every word, subword, combination of words, there is some token or some token ID or some number that is associated, right? For example, he could be 1, this space could be 2, this lives could be 3, this space could be again 2, then any could be one number, AR could be one number. Okay, so these large language models, they have created a library or a vocabulary that for this word, this is the token ID. For this word, this is the token ID. So understand, tokens are not always full words. They could be a combination of words, or they can be I would say a part of the word, right? So chat GPT or GPT use this particular tokenizer called as tick tokenizer, right? So if I just write here, let's say, what was the sentence? He lives near the river bank. Okay, so it has converted this into, so these are the tokens, right? So these are the tokens that have been converted, right? Now the large language model will take these, convert it into embeddings, and then it will try to predict the next token. And then the next token will be reverse engineered into a word, and then you will get that word, right? So your large language models, your algorithms, they do not understand language. They understand the tokens. The tokens are then converted into embeddings. What embeddings are, we are going to talk about in detail in the coming part, right? A quick yes on everyone if you're able to understand about tokens. Look at this very, very carefully. User is 1248. Lives is 8354. Near is 5860. Yes. Right. So this is tokens. And understand, guys, every large language model might have different kind of tokens, right? Every large language model might have different kind of tokens, right? Gemini can have different tokens. Maybe GPT can have different tokens. Different versions of GPT can have different tokens, right? So this is about the tokens. Now, why are tokens important? Why are tokens important? Because understand, your large language model pricing, whenever you are creating an AI product, your large language model pricing depends upon the tokens. So you should know how tokens work. Okay. Generally, it's a rule that like unspoken rule that two words generally are three tokens. Two words are generally three tokens. Okay. Now, these are the tokens, but the question remains. The question remains. Question is, yes. Question remains, how are we able to understand what is going to be the next token? Okay, so I have a list of token. How am I able to know what is the next token? How does large language model figures that out? Okay, so now look at this very carefully, everyone. This is important to understand. Okay, quickly tell me in the chat if you remember what this is. Tell me in the chat if you remember what this is. Yes. Cool. So in your junior grade, you might have learned about this equation. Okay, this is an equation of a line. Okay, this is an equation of a line, which is you have a line, any line, and this is x-axis, this is y-axis, this is m, and this is c. Okay, you don't have to remember this right now. Just look at this equation, y equal to mx plus c. Okay, so y is equal to mx plus c. Okay, so this is the equation of a line. It means to say that if you have the equation of m, if you have the value of m, and if you have the value of c, then for every value, any value of x, you should be able to find the value of y. Okay, so in this diagram, if I know that this is the line, if I know that this is the value of x, then I should be able to know what is the value of y by using this equation. Okay, this is a simple line equation, right? Simple mathematics, right? So now if I have to find the value of y equal to mx plus c, let's say I need to find the value of m and I need to find the value of c. Can you guys tell me How would I find the value of M and C? How would I find the value of M and C? Tell me, think about this. How will I find the value of? Yes, I think on Zoom there are almost 900 people in the call today. Cool. So understand what I need to do is, in order to find the value of M and C, I need to have two known values of X and Y. I need to find 2 points which are on this line, which actually go ahead and respect this equation, which are there on this line. Okay, so I'll take two samples. Okay, I'll take X equal to 1 and Y is equal to 1. Okay, and I'll take another point, X equal to 0 and Y equal to 2. Okay, I'll take these 2 points, right? So the equation is Y is equal to mx plus c, which becomes 1 is equal to m into 1 plus c, which means 1 minus c is equal to m, right? This is the first equation, right? The second equation is y, this is y, is equal to m into x plus c, which means 2 is equal to c. The value of 2c is 2. So the value of m is 2 minus 2 minus 2, which is 0. Just a moment. Yes. Yes. So 1 minus c is equal to m, which means 1 minus 2 is equal to m. Minus 1 is the value of m. Right? So now we have a value of c, we have the value of m. Right? Everyone, tell me a quick yes or no in the chat if you are able to understand this. Everyone. Yes. Right. So now listen very carefully. Okay. I have tried to use this mathematical analogy to help you understand how language models also work, or any kind of algorithms work. Okay. So understand, in order to predict the value of y for a given value of x, you need two parameters. You need 2 points or value of two parameters, which is m and c. Right. Now in language or in algorithms, we have, so large language model is nothing but a huge multi-layered formula where there are billions of parameters. There are billions of parameters. And in this parameter, once you go ahead and give the input of words, it will try to predict the value of y. Okay, so in a linear equation, you have two parameters. So you need 2 points, right? X and y, two values of x and y, right? But in a large language model, you have billions of parameters, right? So you go ahead, give a lot of data, not just 2 points. And then you are able to send it to a formula, like a big, complicated, huge formula. And you keep on figuring out the value of parameters. And by training, by going ahead and giving this data to the large language model for a maximum number of time with as many data qualities as possible, you are going to find what gives you the right value of next token. Right? I'll help you understand this again. In a linear equation, we have y is equal to mx plus c. To understand the value, so we want a situation so that for any value of x, I should be able to find the value of y. But I cannot do this right now because I have, I need to figure out the value of two parameters, m and c, right? So what I'll do is I'll just pick up 2 points which I know, and I'll try to find the value of m and c because of that. And then I can go ahead and put a full equation. And then with this equation, I can find everything. Okay. So this equation that we have just found right now, it has become y equal to mx plus c, or y is equal to minus x plus c, or y is equal to 2 minus x. Right? Now I can put any value of y, any value of x, and I can get the value of y. Right? Now you scale this particular formula for maybe billions of parameters. Right? Once you do that, you have an algorithm which is able to predict what is going to be the next token. Right? A quick yes or no, everyone, if you are able to understand this. We are going to go deeper. Yes. So now you have to, from this analogy, you have to have one takeaway. Takeaway is that you need to determine, so in any formula, what you need to do is you need to determine the value of parameters. Okay, you need to determine the value of parameters. And value of parameters, how can you determine? You determine the value of parameters if you have some known inputs and outputs. Right? So in a linear equation, this value of x is the input, this value of y is the output. Right? Now, if you want to understand the value of input and output, if you want to understand the value of parameters, determine the value of parameters, you need some values of inputs and outputs. Right? Now, in large language models, what we do is, we have a huge formula, like a multi-layered formula, which happens iteratively, where we have billions of parameters. Okay, so this is a line. If this is the C, if this is the C, then this is a line. If I just change the C to something like this, the line will differ. Okay, so what we do is we try to change the parameter to see if the algorithm is working correctly or not. Okay, consider these parameters as small dials. If you tweak one dial, something is going to change. If you tweak one dial, one value of output is going to change for the input. Right? Now, let me go a bit more detailed. Right? Cool. Yes, but before that, a quick yes or no, everyone, if you're able to follow everything so far. Yeah, cool. Now let's go ahead. Okay. Yeah. So one takeaway from whatever we have discussed right now, you can forget anything, but just remember one thing. If you have more data, you can find the value of these parameters, right? If you have more data, you can find the value of these parameters. That is it. That is what you need to take away. Okay, I'm going to tell you how it works. Okay, so whenever a large language model is created, we create a large language model in 3 phases. The number one phase is the number one phase is the pre-training phase. In the pre-training phase, we collect data from multiple places. We collect data from internet. We collect data from books. right? And we also go ahead and collect data from transcripts, subscripts, or maybe subtitles and so many places. Okay, we take this data and then we clean this data. Okay, so data that is coming from unauthenticated forums or other places, we are going to remove it, and we are only going to keep the right data. Okay, and this data is actually terabytes of data, right? After we have this data, we are going to clean this data. Once the data is clean, we are going to put this data line by line. Okay, line by line, as in we are going to take this data and then we are going to train our model with this data. How the training is done, let me show you. Okay, a quick yes or no, everyone, if you are able to see the screen, if you are able to see the diagram on my screen, like there is training data, tokenization, and everything. Right? Cool. So look at this. Look at this very carefully. It is very important. So what is happening here is you have training data, right? In this training data, you are going to take sentence by sentence and you are going to tokenize this data. Tokenize as in whatever tokenization mechanism that you use. Let's say you have a word such as he lives near the river bank. He lives near the river bank. Okay. So in this, what will happen is that let's say this sentence is written in your training data. So you have crawled the internet, you have the training data. In the training data, this sentence is written. So there are billions of sentences like these, right? So what you will do is you will take this part, river, okay, till river, and this will become your input, right? And as I have told you, the purpose of a large language model is to predict the next word. So if your language model is working correctly, then the next word should be bank, right? So we have taken the sentence that we know, we have divided the sentence into two parts. First part is the input, which is the value of X, and then we have bank, which is the value of Y. This is the output, right? So now what we are going to do is we have this data, we are going to tokenize this data. So we are going to create the tokens. I have told you what tokens are. Every language can have their own kind of tokens. And there is a vocabulary. Just for he, there would be a token. For space, there would be a token. For LIV, there would be a token. So there are different kind of tokens for different kind of languages. Okay. There are open source libraries available for the tokens. Okay. So you are going to convert this into a token. Then once you have the tokens, these tokens are going to get ingested into a huge formula or a huge algorithm called as transformers. Okay. This transformer, you don't have to get afraid with this word. This transformer has two things. Okay. One, it has a very big, complicated mathematical expression. I have shown you a very simple mathematical expression, y equal to mx plus c. Imagine if y equal to mx plus c has more than a billion parameters, how it is going to look like, right? That is the formula that is inside this. Okay, so we have a large mathematical expansion and we have the parameters of these expressions, right? Y equal to mx plus c. We do not know what is the value of c. We do not know what is the value of m, right? So right now the variables are random. So we are going to give this data to this. Okay, this algorithm is going to run. And this algorithm will try to predict the value of next token, right? And this value is going to be random because we don't have any value of parameters right now. So it is going to be random. Okay. So we are going to get next word. Maybe the word is bank, but it is telling XYZ because right now it does not have any parameters, right? So it is going to do XYZ. Then what we'll do is we will see what is the actual token. Then we will calculate the difference, right? We will calculate the difference. What is the difference between these two? Okay. So understand, guys, large language models are probabilistic models. Large language models are probabilistic model. Okay. if I give one prompt to GPT and you give the same prompt to GPT, can you guys tell me if we get the same answer or different answer? Let's say if I give a same prompt to GPT and you give the same prompt to GPT, what do you think? We are going to get the same answer or a different answer? Yes, we are going to get different answers because these are probabilistic models. So understand, the output of this machine would not be XYZ. The output would be that I think these could be the words that can follow. Okay, so large language models do not give you one word. They give you probability of the next word. For example, they will tell you that the probability of XYZ being the next word is 0.1. The probability of ABC being the next word is 0. Maybe 2. The probability of bank being the next word is 0.01. Right? So these large language models, they do not predict one word. They predict probabilities of multiple words, and then they choose one of the words at the top. Right? If you want to choose the word with the most probability, top probability, then you tweak a parameter called as temperature. You can read about temperature at your own time. Okay, so you are going to have different kind of answers, right? And this is the reason why different kind of answers happen. Okay, LLMs are indeterministic or stochastic, or I would say indeterminate in nature because they are probabilistic. They do not give you exact word. They try to predict what is the probability of that word, and they pick one of the words with the highest probability, and then they show you. Okay, so tell me guys if you are able to understand why same prompts can have different outputs in GPT. Tell me yes or no if you are able to understand this. Right. Cool. So we have this, right? This is probabilistic. That is why this is indeterminate in nature. Okay. And for that, AI PMs have to write evaluations and all, which we are going to talk about recently, right? After we have done this, what will happen is that, let's say the probability of bank should have been 1, for example, but the probability of bank is actually 0.01. So it is going to calculate the difference, and it is going to tell the parameters again that no, it was wrong. And the algorithm is going to reset the value of parameters again, right? The value of parameters are going to get adjusted, right? And as the values are adjusted for n number of sentences, almost for billion number of sentences, you will eventually have the value of parameters which are able to predict the next word with most accuracy, right? So this cycle is repeated billion number of times on all the training data, is done billion number of times on all the training data in order to go ahead and make you a large language model which is able to predict the next token with a lot of confidence, which is actually meaningful. Right? Everyone on a scale of 1 to 10, 1 to 5, tell me if you're able to understand this. Cool. Now look at this very carefully. Okay, I'll just repeat it once more. Okay. So what happens is we have, just give me a moment. Yes. So we have came to the conclusion that this large language model is nothing, but it's a large formula. Now, in this particular mathematical formula, we need to have the right value of parameters. If we have the right value of parameters in the line equation, there were only two parameters, but here there are billions of parameters. Okay, there for two variables, we are able to find the value of the equation just with the help of the value of parameters, just with the help of 2 points, two input and output data, right? But here, because we have to find billion parameters, we need a lot of data. So what we'll do is we will crawl all the internet, we'll get as much clean data as possible, and then we are going to put sentence by sentence in this LLM. Okay, so what we'll do is we will take a sentence, let's say how LLMs work, right? This is going to be tokenized. Okay, after tokenizing this, we are going to put how LLMs in the input part. And then we are going to compare this to the output part. So understand, this is the input and this is the correct output, right? So we are going to put how LLM into this. It is going to get embedded. It is going to run through the system and it is going to generate a random result. Then what we'll do is we are going to go ahead and check what is the difference between this result that it has predicted, the probability, and between this, the real sentence, real word, real token, which is work, right? And then we are going to have something called as a loss function, which is going to help your large language model function or the formula to improve. And when it keeps on happening multiple times, the parameters will keep on adjusting. And in the end, you will have a large formula which has almost the right value of parameters, right? So the purpose is to find the value of parameters, right? Yes. Everyone, now a quick final yes or no if you're able to understand this. Yes. Yes. Cool. Now, yes. So this is how a large language model operates. Okay. Now there are few things that you need to understand about this. Okay. So understand these as parameters. Okay. What are parameters? Parameters are like a billion knobs which you can go ahead and change with your training in order to make sure that it is able to predict correctly. Okay. So this is what happens during the training phase, right? But if you have just trained a large language model on the internet data, you are going to get a good next token predictor, but you will never get a helpful personal assistant like ChatGPT, Gemini, or Sonnet, or something like that. Okay. So in order to make sure that your LLM is behaving in the right way, you need to do something called as post training. So in post training, what we do is we collect the data. Okay, we collect the right data. So what we'll do is we will create synthetic data in the form of input and in the form of output. Okay, we are going to feed this new curated data to our large language model that we have created from here so that it gets a personality. Okay, let me give you an example. So this is what the post-training data look like. Understand, from the internet, the data that we have collected, that data could be maybe rubbish. It is not having the right tone. It does not know how to speak. And there could be so many errors in the data. Okay. So after training the large language model, giving it a base functionality, we go ahead and we create something called as a post-trained model. In post-trained model, what we do is we go ahead and give it the inputs and we give it the set of outputs, right? For example, I just failed my exam. I feel hopeless. If this kind of answer, like question is asked to an LLM, it should respond in this way. I'm sorry you are feeling this way and this. It will not be harsh. Okay. And then the LLM learns from this. It identifies a pattern and then it is able to get more empathetic and constructive. Right. So post training is a super important thing that you should know as a product manager. And I'm sure everyone is aware about Claude. Claude has a full constitution which they feed to their large language model in order to make sure that they are able to create ethical and transparent AI. Right? So, what happens in post training? What happens in post training? In post training, your base model or the model which you have just trained, it actually converted into a helpful assistant. Right? So these are the three phases of large language model creation: pre-training, training, and post-training, also called as fine-tuning. Okay. Everyone, a quick yes or no if you are able to understand everything so far. Now, let's go ahead. Okay. So, yes. Now, an important part here is, yes. Now, an important part here is, okay, which no one asked, which is very important. Okay. So, understand the whenever you are working with the language, there is a complication in the language. So, English or any kind of language, it has a complication that it works on the context. Context means Virat Kohli likes his bat. Okay, or a better sentence is Virat Kohli throws the bat. Right? Now, if you do not know about Virat Kohli, who Virat Kohli is, then this bat can have two meanings. It can either be the creature bat, right? The vampire bat, and it can also be the playing bat, the instrument that which we play cricket or baseball, right? So now understand, this is one sentence. Okay, the other sentence is he deposits the money in bank, right? And the other is he lives near the river bank. Okay, tell me everyone if you are able to understand what is the difference between the bank here and the bank here. Yes or no? Yes. Right. Cool. So we are able to understand this, that there's a difference, right? But understand the algorithms before transformers. So transformer is an architecture. Okay. Before transformers, whatever the formula that were used, they used to work one word at a time. Okay. But understand, okay, so this is an important question. Think about this and then answer me. How do you know that this bank is actually a financial organization and this bank is actually a bank which is near a water body? Okay. Tell me, guys, how are you able to know this? Yes, very good. So if you look at the content, so how we're able to know is the bank, there is money, there is deposit, right? Similarly, in this bank, there is a river, there is a live. right? Near, right? So before transformers, what used to happen was we were trying to fetch the meaning of the sentence one word at a time, right? But now, but now in 2018-19, a team at Google's DeepMind created a research paper. Okay, published a research paper. The research paper was Attention is All You Need. Okay, you guys should search for it and try to read the research paper, at least with the help of ChatGPT. Okay, so it's an amazing paper. I would say whatever we are looking at GenAI right now, it is because of this particular Nobel paper, okay, which came out of Google and DeepMind, right? So what they proposed is that rather than only looking at one word at a time, whenever we are trying to predict the next word or whenever we are trying to understand the meaning of a sentence, we should try to look at the complete sentence at once. So if I want to understand the meaning of this particular word, I should look at all the words. I should look at all the words. If I'm trying to understand the meaning of this word, I should look at all the words, right? Which means that if you have a sentence with 10 words, it is going to get compared and understand the context of 9 other words, right? So if you are able to understand the word with the help of other words in that particular sentence or context, this is called as context. How long is this word is being like calculated with, right? Now this became a major breakthrough. When you are understanding a word in a sentence from the perspective of other parts of the sentence, then you get the true meaning of that, right? A quick yes or no, everyone, if you're able to understand this. The point is, the better way to learn about meaning of a word in a sentence is to look at the whole sentence, right? Very commonsensical, right? But now there was a problem. The problem was these calculations, like understanding the position of one word with respect to so many other words, it is very computationally heavy. And the common CPUs, central processing units, the processors that were created by Intel and the Qualcomms of the world, they were not efficient to do these aggressive calculations, right? But there was one company which was pro in these kind of calculations, because this company used to create the GPUs for games. In games, because you have so much imagery, the imagery also, so if you want to create real-time graphics, if you do want to do the matrix calculation for the real-time graphics in the game, you need to have GPUs. And the company which used to create GPUs, which was NVIDIA, right? And when this transformer model came, where you have to compare every word with every other word, there are going to be so many complicated calculations of the metrics of the words and sentences. The first choice or the obvious choice was NVIDIA GPUs, because they were the only company they were creating GPUs at such a level. Okay, and that is why, although every company has become 2 or 3, but NVIDIA has become 10x. Right? Everyone, tell me yes or no if you are able to understand this. That's cool. Now there are a lot of research that is happening where Google is coming with the different architectures, TPUs, and recently NVIDIA has acquired a company called as Grok, not the Elon Musk Grok, but a different Grok, which are also having a different kind of approach. So it is evolving, but that is a major reason why NVIDIA has shoot up in the past time. Right? Cool. Yes. So cool. Everyone, quickly tell me on a scale of 1 to 5 if you're able to understand everything so far. Everyone. Yes, wonderful. So now what we'll do is we are going to take a quick break of 5 minutes. Okay, I'll start the timer. A quick break of 5 minutes. Go ahead, get up from your chair, do some stretches, and come back. We will start as this timer ends. Okay, come back soon, everyone. Hello, everyone. Welcome back. Yes. Cool. Tell me I'm back in the chat if you are back. Cool. Amazing. I think everyone is back. Let me just go ahead and start it again. Cool. Wonderful. I hope you guys are getting some value from the session. Okay. I hope you guys are getting some value from the session. Yes. Guys, we are going to go slow because there are so many people who want to keep with the pace. So I'll not change the gears. Yes. The purpose is to be helpful to as many people as possible. Yes. And many of you, I believe, are learning all of these things for the first time. So I completely empathize with you. I honestly took more time to learn all of these things than I'm giving you. Yes. Yes. Everyone, I have posted a link in the chat. If you are liking the content session, so like the content of the session so far, I would appreciate a comment in that particular post. I have shared a link in the chat. Go ahead, post your honest feedback on that particular post. That will help us help more people like you. Okay, we are trying to keep this content free for as many people as possible. And if you comment, this is going to reach a lot of more people, which are going to get more value. So if you are getting the value, don't keep the value to yourself. Go ahead and share it with others. Yes. Cool. So I hope everyone is back. Now, everyone, look at this. We have talked about we have talked about post-training, pre-training, and training. This is how large language models work. And understand, it is important for you to know this information, because how can you build on top of LLM if you do not know even the basics of the same? Okay, so this is not non-redundant information for you. This is an important piece of information for you. Okay, yes. Now, with that being said, let us try to understand the Gen AI ecosystem now. Okay, so let me just go ahead and talk to you about the Gen AI value stack. Okay, so in Gen AI, the value is not only in, let's say, creating the models or providing the infra. There is so much more value that you need to understand. Okay, so this is a Gen AI value stack that we have created. Okay, so there are various kind of categories, segments, and companies that operate in these segments. Okay, the first or the basic layer is the infrastructure layer. The companies which are giving the compute, the data, the platform, and the GPUs, and now the TPUs. These companies are generally the Groks of the world, the NVIDIA of the world, the AWS of the world, or the Vertex AI or Google of the world. Vertex AI is by Google. These provide platforms where you can train your models, you can host your models, and you can store data. Right? This is level number one, or the basic level. Right? The second level is the model layer. In model layer, what happens is these are the companies who are actually creating the large language models for one purpose, general purpose, or multiple purposes. Right? So here we have companies which are creating large language models, small language models, and which are training these models. Right? Here, a prime example is Anthropic, OpenAI, Grok, and Google as well. Right? The third layer is application layer. The application layer is the utilities and the use cases. Now, this is where most of the value will be created, which is now you are using large language models, and now you are trying to build products and experiences on top of that large language model. For example, you have access to the internet. Now you build a website on top of that internet, right? That is the value of the application layer. Similarly, in India, we have UPI. Now people are building so many apps on top of UPI. You have Paytm, you have PhonePe, you have Jar, you have Amazon. So many people are building their payment system on top of that UPI, right? So this is a very, very important layer for you as an AI product builder, right? You have to understand that now that model and infra is available to you, how you can utilize it in order to serve even more people, right? And then we have the service layer. In the service layer, we have people or companies which are just using these products in order to create value. For example, there are agencies like TCS, Real Fast, who are helping people or businesses improve their throughput and contribute some value by using these products, right? So this is the Gen AI value stack. Understand, as a product manager or a product builder in AI, you never have to you never have to only create models. There are so many layers at which you can go ahead and work, right? Consider this like an interesting analogy that I found recently, that this is like the refrigerator. This is like the refrigerator. Okay. But this application layer is like Coke, right? Now that the refrigerator is available, you can create a product like Coke that can have a shelf life of months, right? So now it is up to you as an AI product builder, AI product manager, entrepreneur, how you are able to utilize these models and infra which are now available to you at a fraction of cost in order to build applications on top of it and create value for the customers and the business, right? This is a very, very, very important slide for you to consider, because many people think that if I want to be an AI PM, I have to work on large language models, I have to create large language models, I have to train and have so much technicalities. No, if you just know how to interact with large language models, if you know how to understand the needs of the customers, if you know how to create business out of the same, if you have good product sense and some technical expertise of LLMs, you should be able to build some amazing applications, right? Lovable, Gamma are examples of the same, right? Everyone, a quick yes or no if you are able to understand this Gen AI value stack. Right? Right now, all of us are here. All of us are here. We are using these LLMs in some or the other way in order to go ahead and do these things, right? Yes. Now talking about the real part, the AI PM part. Okay. I do not want this session to be surface level. That is why I have started with the technicalities first before going into the AI PM part. Okay. So now there are, based on what I have told you in the form of Gen AI value stack, there could be three kinds of PMs, right? The first PM is the AI enabled PM. 100% of you are AI enabled PMs. If you are a PM, you are 100% an AI enabled PM, because you are using tools such as GPT to create your PRDs, Lovable to create your prototypes, Notebook LM for your research, Anytime to create your agents, Atlassian Intelligence to put your Jira tickets, right? So if you are a PM in this day and age, you are already an AI enabled PM, because I am sure you are using AI, right? So people who are PMs in this group, in this chat, can you please tell me which company that you are working with and what tools are you using? Can you please tell me the company that you are working with and what tools are you using? Let's say I have written HelloPM. We use Notebook LM and Relay. Everyone, tell me please. EXL, Copilot, Dell, Copilot, Dunnhumby, Copilot, Figma Make. Very good. Amazing. Cool. Right. So all of you are AI enabled PMs, right? This is the first categorization. Everyone is that. So you don't have to worry much about it. And guys, if you people are interested in learning about how to use AI tools as a PM, okay, so tell me yes or no in the chat if you guys are interested to learn how to use AI tools as a PM. A quick yes or no in the chat. Cool. So, okay, have you attended any of our master classes in the past? Okay, so on our YouTube video, okay, if you go to our YouTube channel, if you go to the HelloPM YouTube channel, you should be able to see this page. And if you go to videos, you should be able to see the two videos. One video is how top 1% product managers leverage AI. This is very important video where I have shown you how you can use Google AI Studio and anti-gravity in order to become a better PM. Plus, there is one more video which was around, just give me a moment. Yes, AI tools for product managers. Okay, I will also include this in the resources that I'm going to send you. You just have to remain till the end of the session and submit the feedback form. Okay, so people who are looking for recordings, people who are looking for resources, notes, and everything, they'll be shared with you after you have submitted the feedback for the session. Just remain till the end. Okay, cool. So this is about the AI enabled part. The second is the AI product PMs. Now, these are the PMs who are in the arena. They're actually getting their hands dirty with AI, building AI, right? So here we have two kinds of PMs. One is the core AI PMs. These are the people who are working on the infra or the model layer. They are working on the infra or the model layer, right? So these are the people who are working and creating Vertex AI, Pinecone, GPT, Anthropic models such as these, right? So if you are a PM who is working on models, infra, you are a core AI PM. Generally, you need to have a strong background in data science, artificial intelligence, machine learning in order to become a core AI PM. Right? I'm not saying that you cannot become an PM at OpenAI or Claude or Anthropic if you do not have a data science degree. They also have someone called as applied AI PM. So what is an applied AI PM? Applied AI PM is where the opportunity is. Applied AI PM is people who are leveraging these tools, and this infrastructure in order to build products on top of the same. So product manager who is building ChatGPT, Lovable, Grammarly, Notion AI, or they are improving the internal efficiencies of their, let's say, company by using these core infrastructure and models, they are called as applied AI PM. So who's an applied AI PM? Applied AI PMs are people who are using these core technologies in order to serve their business and customers. Right? And this is where the biggest opportunity is. This is what we are going to learn. This is what I have told you so far. Right? So guys, can you tell me what are you right now and what is your aspiration to become? So you can tell me that I am an AI-enabled PM and then I want to go ahead and get into this. Yes. Very good. Yes. So be it. So be it. So be it. Yes. Now we have talked about AI PMs. We have talked about how large language model works. Now let's talk about the useful part. Okay. The useful part is how do you build products on top of large language models? How do you build products on top of large language models? Right? A quick yes on everyone if you're able to understand this meme. Look at this carefully and then tell me if you're able to understand this meme. Yes. Wonderful. Now I'll show you one product. Okay. So there is an amazing product called as Chat PRD. I'm going to show you how these kind of products are created. Okay, what is the architecture behind the scene, what they are thinking, right? So the product is Chat PRD, and this product does a very simple thing. Very simple thing. The product, a very simple but a very useful thing, which is you give it an idea, you give it an idea, and it will convert it into a clear requirement document. So it creates a PRD or a product requirement document from the initial idea that you give it. To understand, if you want to create a PRD, initially you have to collect all the information, do the research, structure it well, get it approved, and do so many things. But now with AI, with Chat PRD, what you can do is you can just give it an idea and it will be able to convert an amazing PRD for you. Right? This is what this product does. Okay. And this is actually a pretty popular product. Okay. But how does this product works? So it's a very simple product which is created just with prompt engineering. Okay. But understand, everyone, AI, technology, LLM is just one part of product management. Whenever you as a product manager are looking to understand a product, tear down a product, look at the product in detail, you should look at the product with at least 5 lenses. Right? What are the 5 lenses? Remember this. This is very important. Okay. No matter AI or not, this is very important. Okay. So we are taking a product Chat PRD and we are going to look at it from 5 angles. One is, what is the value for the user? A product never works if it is not creating something helpful or it is not solving a problem in the life of the user. Second is business value. What is the business value in this product? Right? How will the business make money if you are investing money in building this product? How will you make money? Right? Design. What is the design? Is it usable for people or not? Right? Feasibility. Is it feasible? Like whether this idea can actually be realized with the help of large language models or not, or any kind of technology. Right? Then we have growth and adoption. Just creating the product is not enough. If you are not able to grow the product, get it adopted, make money out of it, then it is useless. Right? So these are the 5 angles through which you should always consider looking at a product when you tear down or try to understand the product. Okay. This is an important slide, everyone. So please tell me yes or no if you are able to understand these 5 points. Yes. Although in AI products we have 8, but we tell you in that advanced module, there is an octopus framework out there that we have created. But understand these 5 are super essential. Okay. So now I have told you about the product Chat PRD. Okay. Do you think that Chat PRD as a product, does it solve any problem in the life of the users? Can you guys tell me in the chat? Does it solve any important problem in the life of the user? Yes, it saves your time as a product manager because you have to invest a lot of time in creating these, right? Yes, very good. Very good. Yes. Now, it helps you, right? So there is clear user value, right? Then there is also some business value. Business value is that if you are saving time for product managers, then product managers would be willing to pay. At least their company would be willing to pay. Okay. And you can charge money in terms of every PRD generated or every monthly cost or whatever you want to charge. Okay. So there is real money because you are saving time for an important individual in the company. Right? Third is, and you can work out on monetization part as well, right? Now the third part is design. How do we make sure that it is intuitive? Right? Can you guys think about that? Let's say if we create a product like Chat PRD, how do you make sure that it is very usable and very effective in terms of usage for the end customers, which is PMs? Tell me, guys. What are the different ideas that you have through which it will become more useful? Yes, cool. So there are so many things that you can do. Okay, first of all, for prompting your product, for prompting ChatPRD, I do not need to go to chatprd.com. I should be able to do it from my Slack. So there should be an integration of Slack or Microsoft Teams or something, right? Similarly, I should be able to edit the document. I should be able to export it to Google Docs, Notion, Confluence, or anything, right? I should be able to generate user stories out of this PRD. I should be able to share this PRD with multiple people. So there are multiple things that will make sure that this is usable. I can go to the next level by making sure that whatever the PRD is created, it is created on top of the knowledge base of my company. So I can connect the knowledge base of my company, and then it can go ahead and generate data on top of the same. So that all the PRDs that we are creating, they are rooted in the knowledge base of the company. Right? So this is how you are going to make it more usable or better sense of design. Right? After that, there is a feasibility part. Okay, how do you make the architecture? How do engineers create this? So for that, you as a product manager have to give a flow diagram to the engineers. Okay, so this is a simple flow diagram. So you are going to give a brief idea, which is help me build a product, help me build a fitness product. Okay, or help me build a product through which I can manage my calories, my steps, my eating, my daily habits, right? So you will give idea in a very brief format. And then there is going to be a system prompt, and there are going to be good PRD samples that are going to be collected, connected, and then it will be sent to a large language model, such as GPT, Gemini, or something else. And after that, it is going to, from that, it is going to give you an output that will create a PRD or the user stories. And then it will be connected to Jira, Calendar, Slack, and multiple other applications. So this is a data flow diagram of how this chat PRD is going to work. Right? Yes. Everyone, a quick yes or no if you're able to understand this so far. So how we are going to build this product? We have to put the idea, right? There is going to be an interface for the idea. A system prompt or PRD would be connected, and then the large language model will be taking this input. It will generate a PRD and user stories, and then there will be an integration that the engineer will make with all of these parts. Right? Now we have used some terms. Yes. Now we have some terms, right? One term is system prompt. Okay. So what will the system prompt look like? So this is what a system prompt for this kind of product will look like. Okay. You are a senior product manager at a world-class technology company, and then you are writing all of these things. Let me increase the font size. Okay. So you are writing all of these things, giving it some samples, some approaches, and this is how this thing is going to work. So as a product manager, your primary skill is you should be able to understand what is a good system prompt, what is a bad system prompt. Okay. So for that, what I have done is I have created a guide. Not I, but we, me and the AI, Claude. We have created a guide, which is ultimate guide to system prompts. Okay, which contains some core principles, essential components of a system prompt, advanced techniques, common pitfalls, and iteration framework and evaluation checklist. Right? So this is the guide that will help you create better system prompts. Okay. Everyone tell me on a scale of 1 to 5 if you are finding this guide helpful. If you think this guide would be helpful for you, tell me on a scale of 1 to 5 in the chat. Yes, cool. Now let me show you something else. Okay, so here I have also collected real prompts. Okay, so Anthropic's prompt library is here. These are all the system prompts that Claude uses. So Claude's latest model is using this full prompt, right? Similarly, we have for ChatGPT's official prompt engineering guide. And very important is we have this. This is a GitHub repository which actually contains real prompts, real reverse engineered prompts from top companies. For example, if you want to see what is the prompt that Lovable uses, so you can click on agent prompt, and then you have this whole prompt that Lovable actually uses. Right? Now, everyone tell me on a scale of 1 to 5, how helpful do you find this guide to be? Yes, cool. So I'll share this guide with you. Okay, just you have to remain till the end of the, sessions, and then I'm going to share a feedback form. Once you fill that feedback form, my team will share everything with you. Okay, so this is the guide. Okay, just make sure that you understand this, because system prompts are an important part of a AI PM's job. Okay, system prompt means how do you interact with the AI? If you do not know how to interact with the AI, then it is all unnecessary, right? It is all useless, right? So this is how a chat PRD works. Understand, guys? Chat PRD is a simple product. You just need to have an UI, simple prompt engineering, and then your work is done. Okay, a similar product is Granular. So I'm sure you guys might have used a lot of meeting assistants. Right now in this meeting, we have so many meeting assistants such as Fathom. We have, what do we call it? Otter. We have Fireflies. We have Granular and everyone, right? So I'm also going to tell you how this works. Okay, so we are conducting second case study, which is about this. Okay, so how does Granular, Fireflies, or these kind of meeting assistants work? Okay, so what happens here is, first, you can answer all of these, right? Why it is helpful, what is the business, like all of these things. Now, let me tell you the technical part of the data flow diagram there. Okay, so you join a meeting on Zoom, Google Meet, or anywhere. Then these assistants, such as Granular, Otter, Fireflies, they are going to join that meeting with you, or they are going to collect the transcript or the voice or the audio or the video from the computer's mic and microphone and the video, right? Or the camera. So they are going to do API based or bot based audio capture, right? Sometimes they add a bot, like multiple bots which are added in this meeting, and they can also be API based, which is they are going to call the Zoom API directly in order to get the recording. Okay, so they are going to capture it. Now from the video and audio, they are going to capture the transcript. So they will have the audio. Now they will use a tool such as Google, such as OpenAI's Whisper. So OpenAI has a product called as Whisper, which helps you convert an audio into text, right? Which is speech to text. And similarly, Google also have a platform, right? Where they are able to convert the audio into text, into transcript. Okay, so we have the transcript now. We have collected the recording and all. We have the transcript now. Now, after that transcript, we are going to have a system prompt. System prompt that we have used in chat PRD. We are going to have again a system prompt, and this is what the system prompt is. Where is that? Yes. So this is the system prompt, which is, you are the expert chief of staff and note taker. Given the following meeting transcript, generate a structured and actionable summary that includes following sections: meeting title, action items, summary by topics, and all of these things are going to be mentioned in that system prompt. Right? Once that system prompt is run on the transcript, what will happen? We are going to give it to a large language model, such as Gemini, GPT, or anyone, right? GPT or anyone. After that, it is going to give us the summary, the actionables, and the task, and then they can be floated across Jira, Calendar, or Slack. right? So now I have told you how the architecture of a product is going to look like, which is simply based on an LLM without much customization. Understand all of these connections? If you want to build a full-fledged end-to-end product, you will need an engineer for the same. But if you just want to create the simple automation, you can do this on Relay N10, which I'm going to show you tomorrow. Okay. Everyone tell me yes or no in the chat if you're able to understand how products such as meeting assistants work and chat PRD works on the top of LLMs. Yes. So now everyone, I do not want you to remember all of these. What I want you to do is that you understand what an LLM can do. Okay. What an LLM can do? LLM can do three things for you. Okay. You have to think. You have to learn how to think, not to learn what to think. Okay. You have to learn how to think rather than what to think. Okay. So look at this principle. A large language model can help you do three things. First, it can understand what you are saying. Like, honestly, it cannot understand. It is able to do the statistical reference, but that is almost equal as understanding. So it is able to understand what is being said, what is there in the text, right? Second is, it is able to transform. So if you give it some content, it will be able to expand that content. It will be able to summarize that content. It will be able to create that content in bullet points. It will be able to convert that into code. It can do so many things, right? And the third part is it can also generate content, right? It can do essays for you. It can write question answers for you. It can do so many things for you. Okay. It can generate code for you, right? So a large language model can understand, transform, and generate. Right. And now you have to think that what is the problem that your customers are facing and how can I solve it better with an LLM given these kind of things that I can do. Okay. And now you can look at multiple products which are LLM based. Okay. I can also give you a list after you have submitted the feedback form so you can understand how this works. Okay. So you will not understand AI by just learning about AI or watching my sessions. You actually have to think that, let's say in this product, I have to create this kind of diagram. Okay, I have shown you two diagrams. If you can create this for 3 or 4 products, I'm sure your understanding as an AI PM, at least at a conceptual level, will improve. Right? So this is behind Granular. So this, we have talked about very simplistic products. Okay, at least at this level. But LLMs are not limited to this. The world is not limited to this. Okay, but before I could move to the next session, everyone tell me on a scale of 1 to 5 if you are finding the session helpful. Everyone tell me on a scale of 1 to 5 if you're able to find the session helpful. Yes. Amazing. Super. So now we are going to move to a bit advanced part. Okay. Just give me one moment. I'll have to ask you or something. Yes, everyone. If you are really finding the value in the program, please take a moment. Please take a moment in order to leave a comment on this post. What it does is, when you comment on this, it is going to reach to your network. Okay. And then what will happen is that they will get to know about this. They are going to get access to the content, the community and everything. And they are also going to move ahead. If I get popular, the world learns more. Yes. Cool. Wonderful. So this is about the two products. Okay. Now let's try to go a bit advanced. Okay. Let's say, look at this carefully, everyone. Let's say if I ask Chat GPT that tell me what are the items in my to-do list tomorrow? Can ChatGPT answer that for you? If you ask ChatGPT the question that what are the things that are there in my to-do list tomorrow, or give me the details of the PRD that I have created last week on Confluence. Right. Cool. Right. Cool. So by themselves, these large language model, no matter how helpful they cannot interact with external systems. Okay. Once they interact with external system, we call them agents or workflows. But the interaction with external systems is not so simple. Okay. So understand, let's say what I do is I take all of my documents from Notion. So let's say I have a Notion document and I am asking, let's say, I want to put an LLM on top of my Notion. So let's say I copy all of my documents from Notion. And if I paste it onto ChatGPT or integrate via the API, and I ask ChatGPT that what are the things that are important for me to do tomorrow? Okay, I have pasted all of my content from Notion. I have given it to ChatGPT, and I am asking ChatGPT that what are the things that I need to do in this project tomorrow? What will happen? I hope everyone got the question, right? I am taking all of my Notion documents, putting it in the prompt box in ChatGPT, and I'm saying, please tell me what are the things that I need to do in this particular project tomorrow. What will happen? I'll repeat this again. I am giving a prompt to ChatGPT that this is all my Notion documents. Please take them and give me what are the important projects that I need to work on tomorrow. Yes. Yes. So understand everyone. Yes, understand everyone that every large language model has something called as a context window. Context window. Okay. Context window means I have told you in the past that in order to understand the meaning of a sentence, the transformers or these large language models have to understand the meaning of every word related to every word. Right? That is why, because it takes so much, I would say, calculations and so much processing power, no large language model can have infinite context. So context is the value, the range of value that you can put in the input to the large language model. What is the total length of input that you can give to a large language model is called as its context window. Right? So what is the context window? The largest length of input that you can give to a large language model. Okay. It cannot be infinite because it takes a lot of calculations. Right? That is why this will always be finite. When ChatGPT started, it was very slow, but it was very low, but now they are increasing it. Right? Now what will happen? If now you understand about context window, right? Now if I put all of my document of Notion in ChatGPT and ask it a question, now guys tell me what will happen. Tell me what will happen. Yes, it will go out of context. It will hallucinate. It will give you some wrong answer based on complete confidence. Right? So because it is not able to gather that much context, sometimes it will give you an error that I cannot understand all of this, or I cannot have that much context. Sometimes it is going to hallucinate and give you wrong answers. Okay. So what happens is, now this is very important for you to understand, that if you give a lot of context to the large language model, it just doesn't know what to do, right? It is going to give you false, hallucinated answers. Okay. Even if a large language model have a very large context window, as now large language models are having large context window, then also more the context, if you're increasing the context unnecessarily, the quality of the results go down. Okay. So there is a company called as Chroma who has done this study about a year ago, and they were able to find that with increase in input length or tokens, with increase in input length or tokens, the performance of the output goes down. The performance of the output goes down, right? So you cannot give as much data as you want to the LLM. You have to be selective in your data, right? If you are not able to understand this, you will understand with this meme. Okay. So when you give concise input context to the LLM, then LLM behaves very nicely, very attentively. But if you try to give LLM with too large input context, then they just tend to hallucinate and behave like a kid who ate crayons. Right? Everyone, a quick yes or no if you are able to understand this. Yes. So as a product manager, what you need to do is, as an AI engineer, AI builder, product manager, you always have to go ahead and remember what? A term called as context engineering. Right? Context engineering. Right? So you should be aware about this. After that, you have to tweak your system prompts, do some experimentation, write evaluations in order to understand how this. So in tomorrow's class, I'm going to talk about evaluations so that you understand how you should make sure that system prompts are of the right length and they are having the right kind of instructions. Okay. So this is context engineering, right? So context engineering means, so this word is given by the OG, Andrej Karpathy, who has said that context, who actually coined the term. He says that context engineering is the delicate art and science of filling the context window with just right information for the next step. You are collecting data from multiple places and curating this data along with your instructions into your model's input so that it is able to do the right job in the next step. This is what is context engineering. Okay. And there are multiple methods of context engineering. Okay. One of the methods is RAG. So what I'll do is, right now, I will take 5-10 minutes in order to introduce you to RAG. After that, we are going to again repeat this tomorrow. Okay. So the last 10 minutes of the session today, after that, I'll share the feedback form. You have to fill that feedback form if you want to get all the resources. And then we are going to break the session and then we are going to resume it tomorrow. Okay. So now let me help you understand what is RAG. Okay. Let me go to the file. Okay. Yes. Cool. So let's say, like, imagine this. Okay. This is how RAG works. Look at this very carefully, guys. This is super, super important. Okay. Let me check. Okay. So everyone, please write focus in the chat if you're focusing in the session so that I can move ahead. These last 10 minutes are super important. Wonderful. Yes. Let's go ahead. Now look at this very carefully. Okay. So now look at this. Okay. Now what we do in RAG is, it's very simple actually. Okay. Let's say someone comes to your house. Okay. You have a big house. Let's say you are ultra rich and you have a house in the Camellias and you have a big house with so many rooms. Okay. Now, if you are, let's say your neighbor comes because they are Indian neighbors and they are going to ask you for sugar, that we have some relatives at home and our sugar has run out of stock. So can you please help me with the sugar? Right. So if your neighbor comes to your house and they ask for sugar, what will you do? Tell me in the chat. If your neighbor comes to your house and asks you for sugar or something else, what would you do? Yes. So what you will do is, so what you will do is, so first of all, what you will not do? You will not go around in your house in order to search where sugar is, right? You will go ahead, you will go to the kitchen. You will go to the kitchen. And then in the kitchen, you already know, if it is your home, you will already know where the kitchen is and where the pot of sugar is. And then you are going to take that sugar and you are going to go give it to them, right? What I mean to say is, if you already know where the item is, what is where is the place where this item is likely to be, you are going to go to that place and you are going to fetch that item and then you are going to give it to the person, right? This is also RAG in a nutshell. I'll tell you how. Okay. So what we do is, if let's say I have the whole Notion database, Notion or Google Docs. Okay. So situation number one is, let's say I ask a question. I ask a question that what should be the next step in project X? Let's say, not let's say, this is a real thing. So we at HelloPM are partnering with Figma and Lovable. And this partnership is almost done, where they'll be giving free credits to all of the students at HelloPM from the next cohort onwards, right? So let's say I have maintained some documentation and everything around the same. Let's say sometime I am on leave and my colleague is there when the Figma team calls, right? And now he wants to understand that what have I already talked to them about. Okay, so he can just ask that what should be the next step in project X or project Figma or project Lovable or something, and he will get all the information. Okay, so now there are two situations. Situation number one is, if I ask this question to Google Docs, which has AI on top of it, situation number one is, it will try to search all the documents. It will try to go ahead, ask this question. So it will take this question, plus it will add all my documents and it will send it to an LLM. So the prompt will become, system prompt will become, this is user's question and this is the whole context. Please answer this question. And this context is all my Google or Notion docs. This is approach one. And then the second approach is, not every document would be searched. Not every document would be sent into the context, but only the document where this word project X or something like that is mentioned. Okay, so here I have 100 documents. Here I have only 10 documents where these words or their combination is mentioned in some or the other way, which is relatable to this particular product. Okay, and then this would be added and then it will be going to an LLM. Okay, so in this question, the context is all the documents. In this question, the context is only the document which are relevant to this query. Okay, this is approach one, this is approach two. Tell me, everyone, if you are able to understand this, and tell me which approach is better. Yes, obviously, approach number two is better. Why? Because you are going to save context. If you're using less context, then you have better results. Plus, for every input and output, you have to pay money, right? If your length of the context is larger, you have to pay money because tokens are calculated on the basis of your length of, like your cost is calculated on the basis of token length, right? So this is about this. Okay, so how does it happen? So this is the example of RAG. So how does it happen? I'll tell you how does it happen. Okay, so first of all, what happens is, first we create a knowledge base. First, we create a knowledge base. Okay, so we are going to take documents from everywhere. Let me show you with a vector visualization. Just give me a minute. Okay, I think we are out of time. Can you guys tell me if we should complete it right now or I should leave it to tomorrow? Tell me now or tomorrow. Yes, carpe diem, seize the moment. Yes, cool. So now look at this, okay? So let's say, now look at the use case. We want to build a large language, like an intelligent document. We want to build a intelligent document assistant. So Notion AI. On Notion AI, I can ask a question and then I'll ask a question in the natural language and then I'll get answers from a Notion database. Right? On Google Doc AI, I can ask the question and it will answer from my Google Docs. Right? So how do enterprises can put a large language model on the top of their knowledge base? This is what we are understanding. This is what RAG does. Okay, I'm going to tell you what the definition of RAG, but just in a moment. Okay, let's understand the concept first. So what happens is, the first part of RAG is, let me duplicate this. Yes, cool. So look at this. So the first part is knowledge base creation. What happens in knowledge base creation is, you will have all the documents that are necessary. For example, all the text, PDF, transcript, code, any data that you want to have in your knowledge base, you are going to get this data. After that, you are going to break down this data into small chunks. Okay, you are going to take the data, you are going to break it down by line, by function, by paragraph, so that the search is very granular. Okay, so that the search is very granular, the words are able to be found easily. Okay, so we are going to take all the documentation and all the knowledge base. We are going to break it down into small chunks. After we have break it down into small chunks, what we'll do is, we are going to do a very important step, which is we are going to convert these into vector embeddings. We are going to convert these into vector embeddings. So what is a vector embedding? Now look at this very carefully, super important. What are vectors? Vectors are mathematical. Look at this very carefully. Vectors are mathematical representation of meaning of a sentence or a word. Right? Vectors are mathematical representations of meaning of a text block or piece of information. Right? So it means the vectors are going to have an actual meaning attached to them. To give an example, let's say we have a vector of cat and we have a vector of dog and we have a vector of table. Okay, so we have these three vectors. So what is vector? Vector is nothing but a numerical representation. So it is going to be a list of numbers. Let's say 0.1, 0.2, 0.01, 0.02. This is a long range of numbers. Okay, and somehow these numbers actually represent the meaning of this word. Okay, so here in this case, if I create the vector of cat, dog, and table, then dog and cat are going to be nearby to each other if I measure the distance between these two. And dog and table and cat and table are going to be far apart from each other. Right? If I take another vector, which is kitten, kitten is going to be more near to, it will be more similar to cat than being similar to dog. Why? Because kitten is more equal in meaning or more near to meaning to cat than a dog. Okay, this is a vector, right? So what we do is we have open libraries. So OpenAI has an embedding library through which you can give any data. You can give any data to this, and then it will create an embedding or the vector embedding. This is called as vector embedding. Okay, so what is vector embedding? I'm again repeating. It is a mathematical representation of the meaning of that word or text block. Right? A quick yes or everyone. A, okay. I'm not speaking anything. Okay. Cool. So we are talking about vectors. What is a vector? Vector is a mathematical representation of a text block which represents the true meaning for the same. Okay. So if you have three vectors, cat and dog and kitten and table, cat and kitten vectors are going to be very similar to each other. Cat and dog are going to be somewhat similar to each other. But as compared to cat and dog, this cat and table and dog and table are going to be very much non-similar to each other. Right? So this is vectors, which contains almost the right meaning or the true meaning of a particular word. Right? Now, everyone, a quick yes or no if you're able to understand. I think I froze in between. Cool. Yes. So, okay, I'll take one more moment to help you understand this. Okay. So what will happen here is, let's say we want to understand how cat and dog are similar to each other. Okay. So cat has features. Okay. The features are, is it an animal? Is it an animal? Does it belongs to the loin family? Is it cute? Is it cute? Okay, so three things we have put together. Okay, or let's, rather than cute, I will put cute is subjective. So does it have a fur? Okay, we have a cat, we have a dog, and we have a table. Right? So is cat an animal? Yes, it's an animal. The value is 1. Is cat belongs to the line? Does cat belongs to the lion family? Yes, it belongs to the lion family. Does it have fur? Yes, it has fur. So this is one sample vector. The value is 1, 1, 1. Right? Second is dog. Is dog an animal? Yes, it's an animal. Does it belong to the loin family? No, it does not belong to the loin family. It is 0. Does it have fur? Yes, it has fur. So the value is 1, 0, 1. Right? Similarly, on table, is it an animal? No. Does it belong to loin family? No. Does it have fur? It does not have fur. So 0, 0, 0. Right? So now we have cat is this, dog is this, and table is this. So which means cat and dog are more near to each other in meaning as compared to cat and table and dog and table. Okay. And this is what a vector is. So although I have taken hypothetical parameters, but there are 1300 plus parameters that are considered while giving a vector to a particular component or a text block. Okay. Everyone tell me if you're able to now understand what vectors are. Right? So these are called as features. Right? These are called as parameters or features. Right? So understand, guys, these concepts are not very complicated. You just need to know how to actually learn them. Right? Everything in mathematics also is related to, let's say, real life. This is how mathematicians also think. But the issue is that from that mathematician creating something to you getting something, a lot of information get lost. Okay, so this is there, right? Now this is about the vectors. Now what happens is, what we do is, where is the diagram? Yes. So now we are going to convert all these things into vectors. Okay, we are converting into vectors so that whenever we want to search for the relevant information, we should be able to search on the basis of vectors. Understand? If we do not have vectors, we are going to search by keywords. And keyword matching is not the best way to search for content in the modern age. Keyword matching is not the best way to search for content. So we want to search with semantic meaning. Semantic meaning is these vectors. Right? And after that, once the vectors are created, we are going to use a particular kind of storage to store these vectors, which is called as vector storage. Which is called as vector storage. Okay, some popular names are Pinecone, Supabase, AWS, S3 and all. Right? So this is one version we have created. So now we have a repository of all the content in the vector base. Right? Then we have, so this is knowledge base is created. Now what will happen? The user will send you a prompt. The user will send a prompt that how has Tesla performed in the last quarter? Okay. Now what will happen? You will convert this text, whatever this text is, it will be converted into an embedding. So OpenAI, Google, Gemini, all of these have some APIs through which you can convert this into an embedding. Okay. These APIs are called as embedding APIs through which vectors are created. So you will convert that query into a vector. After that, once the query is converted into a vector, you are going to find what are the similar items. You are going to search for the semantic matching information. And then from your database of vectors, you are going to search what are the information that is similar to this. So which information is similar to the information that is stored in the prompt. Okay, so now you are going to search for the information and you are going to search for top important information. You will not retrieve all the documents. You will only see where the matching is the highest. You will only see where the matching is the highest. Okay, so you will have all of these components, all of these embeddings where matchings are there. And then from the embeddings, you are going to retrieve the chunks, which is the actual text lines. Okay, now you will create a new prompt. The new prompt would be answer the question using the context below. The context is whatever chunks that you have retrieved, which were common, which were related to that. And then the user query will be pasted here. This user query will be pasted here. So now this is the new query. Right? We have done context engineering by finding the right thing to paste in the prompt. Right? After that, this whole query will go to an LLM, Claude, Gemini, or Llama, and then we are going to get the answer. Right? So this is RAG, also called as retrieval augment generation. Right? So you are retrieving the content. You are retrieving the content from your own database, searching through a vector method. Then you are augmenting it. Augmenting means you are now pulling that data, creating a prompt. You are augmenting an LLM call. Okay. And then you are generating the data from the LLM. This is called RAG. It is a super important concept. All the enterprise AI is built on top of RAG. Right? Your Lovable, your Notebook LM, most of the products that you use these days are built on top of RAG. Right? Everyone tell me on a scale of 1 to 5, you're able to understand RAG. I'll definitely do a revision tomorrow as well. Yes. Now, everyone, what we'll do is, yes, now just give me a moment. We are going to just wrap up. I'll share the feedback form with everyone in the chat. Okay, just fill that feedback form because that will help us give you all the resources, which includes that guide for system prompting and all the resources. Okay, just give me one moment. Mm, cool. Everyone, I'm sharing a feedback form in the chat. Just give me a moment. Where is that? Yes. So I have shared a feedback form in the chat. Yes. Go ahead. I have shared the feedback form in the chat. Everyone, please go ahead and fill this feedback form. Okay. So that we are able to understand how we did, how I did, and then we are also able to give you the resources. Yeah. So troubleshooting RAG and everything is actually not a part of this agenda. But in a bigger program, we actually help you out in order to do all of this. Okay, so we also run a paid program at HelloPM. If you guys are interested, you can just go to hellopm.co in order to check it out. All the information is there on the website. If you want to talk to us, you can also go ahead and schedule a one-on-one call from here. Yes, everyone, please fill the feedback form. Once you're done with the feedback form, give me an emoticon on that message. Filling the feedback form is mandatory. Yeah, someone from the HelloPM team can please paste that form on YouTube as well. Yes, everyone, please don't miss out on sharing the feedback form. I've reshared the feedback form. Yes, everyone, please go ahead, fill the feedback form. Super important. Yes, and make sure that you join tomorrow on time. We have so much content to cover today. Let me show you what we are going to cover today, cover tomorrow. Yes, tomorrow we'll deep dive into RAG once again. I'll give you some more conceptual knowledge. Then we'll talk about prompt engineering. We'll talk about fine tuning as well. Yes, we'll talk about fine tuning. We'll talk about notebook LM. We'll talk about fine tuning is an important concept. Yes, then we'll tell you how to use small language models. Then we are going to talk about how to decide between prompt tuning and everything, like prompt engineering, RAG, and fine tuning. And then we'll talk about AI agents. Then we'll discuss how Lovable works. Then we'll talk about AI agents in action. And we'll talk about the AI agent stack. And then we are going to talk about MCPs tomorrow. And then we'll also talk about AI evaluations tomorrow. So a lot of things we have to cover tomorrow as well, guys. Yes, I hope all of you are excited for tomorrow as well. Yes, feel free to invite your friends as well. Learning is better when it is shared. Everyone, please fill the feedback form. I could see there are about 580 people present and only 400 people have submitted the feedback form so far. 407 now. 8, 10. Cool. Wonderful. So I believe all of you got the value from the session. Okay. We keep on doing multiple of these sessions, so basics are covered. For advanced, we have a very like a pretty successful program that we are running for almost 5 years now. So you can also check that. HelloPM.co is the name of the website if you, in case you want to check. Yes. Cool. Well, let me check on YouTube if we have this. Wait, let me see if I can share it on YouTube also. Just give me a moment. Hello PM, view the channel. Let me check on YouTube if you have this. Yeah, I have shared the link on YouTube as well. Yes, I have shared the link on YouTube right now. Feedback from everyone. Cool. Yes, the link is also shared on there as well. Cool. So thank you everyone. I think this was a power pack session. I would recommend everyone to review it on YouTube. On YouTube, there is a link altogether. Okay, so please revise everything. Okay, and tomorrow we are going to discuss a bit of more advanced topics. The purpose is not to give you as much information in your mind. The purpose is to help you understand how to think like a product manager. Okay, and for that you should never be afraid of any new information. Have conviction in yourself. Have conviction in your potential. That no matter what situation is going to come at me, I have seen so many things that I should be able to go ahead and face that challenge. Okay, so I want to build that conviction in you rather than just give you like some random information. Okay, learn how to think. Cool. Thank you, everyone. Bye. Take care. You have been a great audience, and now my throat is giving away. Thank you, guys. Bye and take care. Yes. Come on, guys, go. Session is done. Bye. Take care. Yes. Cool. Thank you, everyone. Bye. Take care. It's a bye from Hello PM. Take care, guys. Thank you. Bye. We'll see each other tomorrow. And people who are on YouTube, make sure before you go, subscribe to the channel. We are actually planning an amazing series of content for you people. Go ahead. Thank you.